Welcome everyone. In this video lecture, we will solve a problem on MOSFET circuit at DC, which is just a continuation of the last problem, that is our problem number 6. So I will share that video on the description link. So the question is, what is the largest value that RD can have while the transistor remains in the saturation mode? So we have to find the RD value. Okay, largest value means simply we can say RD maximum value. We have to find that the transistor, that is say I am saying this transistor is our M1, that will M1 will remain in saturation region. Okay, so this one is the question. So before that I just want to clear that those who are new. So in the last video related to the same figure, we have already derived the value of id. So id value is coming nearly 0.5 milliampere. I will share that link. So id can be easily found by using the drain current equation in the saturation region, and by putting everything we can get this one. So this is, I am just taking this id equals to 0.5 milliampere, and this value the gate terminal, then and this source terminal, and the Vg, the gate value we have already calculated 5 volts. So which is just simply the Vg value will be, this one is Eg, so directly I am writing VDD Rg2 by Rg1 plus Rg2. So if we say, solve this one, so this one is 10 into 10 by 10 plus 10, 10 plus 10 20. So it will come 5 volt. So that we have already derived this one. So okay, and this id value, if we solve this one, the whole circuit, so I am just writing the quadratic equation that we get on the last video, that is our 18 id square minus 25 id plus 8 equals to 0. This will come after solving. In the earlier video, in the earlier one, this rd value we have taken 6 kilo ohm. Okay, this one is also from the last video that we are just taking. This one is vg. Okay, so now we have to find today by the current in the circuit is known to us, that is our id value is 0.5 milliampere. Okay, milliampere id. Okay, so this one is id. I am writing this id 0.5 milliampere. Okay, so now, so before that, the device is in the saturation region, so we have to know the condition first. Okay, so if this one is the id vds curve, so the device is in the saturation region only when this one is our VGS minus VT point. This one VDS should be greater than equals to VGS minus VT. This one is the condition when the device is in the saturation region. Okay, so this one is very important. So this one is the condition. Okay, so what we can say, VD minus VS should be greater than VG minus VS minus VT. This VS cancel, or it is same potential. So VD should be greater than Vg minus Vt. Okay, so one more thing, this Vd value will be, Vg value will be 5 minus Vt will be 1. So we can write for saturation case, this should be Vd value will be, for the saturation case, if there is a number line 4. Okay, this one is our Vd. Okay, so if we put a Vd value more than this, okay, in this side Vd, okay, like 5 6. Okay, so the transistor remain in the saturation region. Okay, that we have already conclude from this one, means when Vd equals to 4, greater than 4. Okay, this one. Vd equals to greater than 4. It is in the saturation region. So now the minimum value of Vd will be 4 and maximum it will be 5, 6 like that. So now we have to find the Rd value. Okay. So this value will be VDD, that is our 10 volt, and this should be our VD. So just that I am writing, and it should be RD. Okay. And if this current is ID, which is known to us from the last video, we have already calculated ID 0.5 milliampere. So this ID value one can write VDD minus VD by RD. So RD value will be VDD minus VD divided by ID. Okay. So now in the question they are asking the maximum value of RD or largest value. Okay. To make RD maximum, to make RD maximum. Okay. Our VD should be minimum. Okay, because we are subtracting something, so RD max will be VDD minus VD minimum. So this can be our VD minimum 4 volt by ID. Okay, so VDD is our 10 volt minus VD minimum 4 volt and ID 0.5 milliampere. So 6 by 0.5 into 10 to power 3, okay, milli. So it will, so we can also write 60 by 5, and this one is kilo ohm. Okay, kilo. So this should be 12. So 12 kilo ohm. So the RD max value, here I am writing RD max value is 12 kilo ohm. Okay, I am highlighting. So this one is the answer for our question. Okay, RD max we have find by use, but ID simply ID. Okay, so if one can say, if you take a higher value of 5 or 6, for example, I am taking 5 value, so the resistance value RD will be lesser. That can also we can find the RD value at VD equals to 5 volt. VD 5 volt here. So somehow VD equals to 5 volt. Okay, so it should be VDD minus VD, that is your 5 by ID. So better to write 10 minus by 0.5. Okay, kilo. So it should be kilo ohm milli. So 5 by 5 into 10. Okay, if we remove this decimal, 10 will become. So it should be 10 kilo ohm. Okay. So RD at this point, so at this point RD value will be what? RD value will be just 10 kilo ohm, but here RD will be maximum 12 kilo ohm. So in the question they are asking the maximum value of RD, so we can easily find the RD value. So RD max value will be 12 kilo ohm. Okay, so this is all about this simple question. So for more detail, it will better to go for my last video, in which I have already covered, means how to find this ID value and this VD value. So VD value, oh sorry, VG value already calculated here. So and this one is the very important concept, means saturation area, when VDS should be, this one is the condition, VDS should be greater than. So here we have find the condition for saturation, VD should be greater than 4. So here 4. So in this area, the device is in the saturation region. Okay, it may be VD 4, 5, 6. So minimum, for the minimum VD, it will give the maximum RD that we have already find by, for RD maximum and VD minimum. So this, like that we can find. So here also for RD equals to 5, 10 kilo ohm. This is all about this simple question. So thank you for watching this video. So here the RD max will be 12 kilo ohm, and this one is the problem from the microelectronics circuits book. So thank you for watching this video.